G'day, welcome to this episode of the ADF Architecture TV channel. My name's Chris Muir, I'm an ADF product manager working for Oracle Corporation. Now, in today's episode and the following set of episodes, we're going to look at, from a development perspective, build and deployment options. So in this set of episodes, we're going to look at all the options that developers have in terms of building their ADF applications. So what we're not going to do is look at the actual nitty-gritty technical details, but rather sit back and think about the whole build process, and in the following episodes, the whole deployment process, work out the individual steps or processes along the way, and then look at, hey, what options do we have for each one of those processes, each one of those steps, and well, essentially what the pros and cons are. So let's delve in and let's start talking about the ADF build process. So what I'd like to do to start off with is talk about the terms build and deploy more generically, more than from just an ADF perspective. The reason I need to do that is because JDeveloper comes with a tool called ojdeploy, and this product, this tool that's provided in the actual RDE, which you execute from the command line, is actually a build tool, not a deploy tool. The reason it's called ojdeploy is for historic reasons. Now, because of that strange naming convention, let's just take a step back and talk about, from a software development perspective, what actually building software typically means. So the act of building software from source code typically includes the following steps: checking out your code from, say, Subversion or another version control system, compiling and linking the code. Now, linking is something that Java programmers probably aren't too familiar with, but it's certainly something you had to do with older languages. Then, because applications and source code is normally dependent on other source code and libraries, you need to build things in a specific order and consider the dependencies and manage those dependencies. Also, you then, with the end artifact, you need to package it. Okay, and in Java we have the concepts of jars, is, and wars. These are all the deployable artifact packages that, in context of ADF, would go onto a Java EE server, such as WebLogic Server. Then, of course, we are deploying the application. Hopefully you have automated tests in place, so you're running tests. Otherwise, you're possibly doing manual tests. And if you really have your act together, you're creating automated documentation and release notes from your Java docs and the other type of constructs that you have in your code. Now, in context of this specific episode, what we're looking at is the act of what we're going to call building the software, specifically compiling it, dealing with dependency management and build orders, and packaging the code into jars, is, wars, and ADF libraries. In the next set of episodes, we'll look at the actual deployment of the jar, EAR, or war, or ADF library jar to the WebLogic server. Okay, so we're really separating those concepts out for this set of episodes. So specifically considering the build process of an ADF application, what do we need to think about? What processes or steps are there, and what choices do we have along the way for, say, tools and different ways of doing things? Well, essentially there's 5 things you need to consider. The first is JDeveloper deployment profiles. Second, the actual tool to build your application. Third, then dependency management tools and the build order of your application. Fourth, post-build modifications, potentially using WebLogic Server deployment plans and other options. The fifth part that you should really consider, because it is a best practice in software development, is that of a continuous integration server. And really this loops around all of those 4 steps. You're integrating those 4 previous steps into your CI server of choice, being Hudson or Jenkins as example. Now, deployment profiles is hopefully something I don't need to teach you about. It is something that basically developers get introduced to fairly early in terms of JDeveloper and ADF application development, because they want to deploy to an integrated WebLogic server to test their applications, and there are deployment profiles that do that. But just to recap on a deployment profile, you'll basically know that the end artifact that gets deployed to a WebLogic server is a jar, an ADF library jar, an EAR, or a war file. Now, what actually gets included in those artifacts, the configuration of what gets included, is what the deployment profile exists for. The deployment profile is basically the configuration set to say, hey, I'm going to generate a war and I'm going to include these files. I'm going to create an ADF library jar and I'm going to include these banner task flows, and so on and so forth. So basically it's the mechanism under which you actually set all those configurations up. Now from there, JDeveloper or ojdeploy, which are your actual build engines, take those configuration sets, take the source code that's configured through those configuration sets, the deployment profiles, and creates the end artifact. Okay? Now you might go, oh, that's all good and well, but what's the alternative? Well, back in the good old days of programming, you might be familiar with the concept of make scripts. And make scripts really did the same thing from more of a programmatic script perspective. And what JDeveloper's done is just turn that into a more of a declarative type option, so you don't have to maintain all these make scripts yourself. So JDeveloper itself supports a number of different deployment profile types. However, for ADF server development, we're most likely to be interested in EAR files, WAR files, ADF library jar files. If we're developing MDS or metadata service deployments, that's MAR files. And finally, if we're also developing ADF business component web service SDOs, we want the business component service interface profile type. So let's now move on to considering actually building the application, or what we called compiling and linking previously. Now from an ADF perspective, that's choosing and configuring the tools to build the application. What choices do we have? Now in this part of the ADF Architecture TV episode, I'm going to take a little bit of a cop-out and not go through all your choices, because in fact on another YouTube channel, the ADF Insider Essentials YouTube channel, we've recorded an episode on ojdeploy. Now ojdeploy is the tool for building your application, not deploying your application, and it really is Oracle's recommendation for building ADF artifacts. ojdeploy can be called from the command line, from Ant scripts. It has other options such as oj server, so you can start up oj server once rather than ojdeploy multiple times. It has a bunch of best practices and a bunch of configurations that are very much detailed in that ADF Insider Essentials episode. So in this point of the ADF Architecture TV episode, can I refer you to that other episode? Take the time out to go and review it. It's particularly useful for developers to understand their options, and it will give you an understanding of why ojdeploy is the best option in terms of building your ADF applications. Okay, so ojdeploy is the tool that's going to build our ADF library jars, our EARs, our WARs, and so on and so forth. It's the tool of choice. But what ojdeploy doesn't solve for you is when you have to build multiple ADF artifacts in a dependency management type order, where you may have, say, an EAR or a WAR is reliant on a number of ADF library jars that need to be built first. So let's talk about dependency management and the tools and choices you have in context of ADF development and building your applications. Now we know from our previous episodes of the ADF Architecture TV channel, in particular the architectural patterns set of episodes, that when we build ADF applications, well, they can be built out of one workspace, or they can actually be built out of multiple workspaces. So you might have a master workspace dependent on a number of BTF workspaces or bounded task flow workspaces, and those in turn dependent on a common workspace. Now from a dependency perspective, you need to build common first, then all the bounded task flow workspaces, and then the master workspace. So there very much is a dependency chain going on there. Now from the perspective of JDeveloper IDE, it does actually track those dependencies. When you turn the common workspace projects or the bounded task flow view controller projects into ADF library jars, which are consumed by the master workspace, through the process of consumption, where you use the resource palette to say, hey, this view controller project on the master workspace is going to use this BTF view controller ADF library jar. Basically, JDeveloper in the JPR files for the specific view controller master workspace, it does say there is a dependency, okay, between the ADF library jar and the actual master workspace itself. But what it doesn't do, JDeveloper, is it doesn't assist you in actually building the applications or the workspaces in the correct order. It will allow you to build them one by one, but there is no tool that says, hey, I've got this master workspace here, and I'll work back the dependency tree to see the direct dependencies and the indirect dependents down the line and build them in a specific order. In addition, JDeveloper has no intelligence about checking out the right version of those workspaces. Okay, so that, we're dependent on BTF workspace, but we're now dependent on version 3, not version 2 or version 1. So again, JDeveloper gives you no assistance in those regards. So this is where we really need to think about bringing in some build management tools to assist that overall build process, checking out the right version code, and basically bringing this all together such that our developers aren't doing this manually, but the tools are taking all the grunt work out of this. Now in those regards, you've really got three options in the Java space. You have Apache Ant scripts, you have Apache Ivy, and you also have Apache Maven. So let's talk about that in a little bit more detail. The first tool to consider is Apache Ant. Now Apache Ant is basically a scripting language, as you know, and pretty much you can script anything in it. So you can script an algorithm to build specific parts of your application in order. Now in Apache Ant you could call ojdeploy, so there's no issue about integrating the JDeveloper build process. But there is a big problem with Apache Ant, is that as your applications and the number of modules gets larger and larger, dealing with your Apache Ant scripts becomes, well, a programming exercise in its own right. Many organizations find that eventually they need to nearly dedicate a set of developers to the Apache Ant scripts just to keep them all up and running. They are, and they will become very brittle. So typically in this situation, you would look to a dedicated build management tool as opposed to this scripting language, which is great for doing lots of little builds and lots of little atomic actions, but not maintaining your whole build process. So in context of dependency management tools, why they are better than Apache Ant and what do they actually provide? Typically, a dependency management tool will allow you to define and track the overall modules as part of your application. So you can think of this as all the different ADF library jars and your main master application, your main BTF workspaces, and so on and so forth. It will allow you to define and track all of those. It would also allow you to version all of those independently of each other, but then track the dependencies between the different modules and the actual version dependency as well. And like we said before, if my module is dependent on your module, but I'm dependent on version 3, this is what a dependency management tool will also do for you. Now, typically, a dependency management tool also relies on some sort of centralized repository where the artifacts, so this is both the dependency management configurations plus the version configurations and the end-generated artifacts, that being our ADF library jars, our ADs and wars, these actual artifacts are placed into a centralized repository. And then multiple developers within your organization can use that repository to actually, well, in essence, check in and out modules, download dependents, download specific version dependencies through a sort of publish-subscribe type mechanism. Now, the real power of these tools is that typically not only are they able to download specific dependents that your current module is directly related to, but they can also download what we call transient or indirect dependencies. So I'm dependent on module A, and module A is dependent on B and C. So not only will it download and download module A for me, but it'll download modules B and C for me to make sure that I've got all the indirect dependencies as well. Now, another situation you can get into with the dependencies is, well, what happens is if there's sort of two versions of the dependencies that you require and there's no actual specified version that you need. Can the tool also assist you in saying, well, in this situation, I think you should always take the most recent version of the dependency that's been checked up into the repository? So one viable tool, one build management tool that you could think about using is Apache Ivy. And coming from the Apache Foundation, it's another free tool. And Apache Ivy is an extension to Apache Ant. What Apache Ivy does is allow you to, in configuration files, ivy.xml files, to define the dependencies between modules and the versions of those dependencies. It then, like we kind of described previously, allows you to check in and out building artifacts from a central repository that all developers use. Now, Apache Ivy is purely a build and dependency management tool. It has no other smarts in it, unlike Apache Maven that we'll talk about in a minute. It is relatively simple to learn, has reasonable documentation, an okay community presence, and without a doubt some previous JDeveloper and ADF customers have used it to build their applications. In fact, you can see this link on the screen was a previous blog entry that I wrote from a previous customer that I worked for using Apache Ivy. But For all intents and purposes, Apache Ivy, well, out there in the industry, it's not really used that much. It is by maybe 10 or 25% of the community, but Apache Maven is really the tool out there that is more the de facto standard for build and dependency management, building of your applications. So let's talk about Apache Maven in a little bit more detail. So Apache Maven, unlike Apache Ivy, is, well, not just a build and management tool. This is one of its primary functions. It's designed to unify or basically standardize the build process across all Java EE applications. So it doesn't matter if you're working on an ADF application, a Spring application, or whichever. Basically, the build process and the way that it's done is, well, a kind of an industry de facto standard. But Apache Maven actually assists in a number of other parts of the overall, let's say, software development process, the build process. A little bit hard to define Apache Maven sometimes. But it can do things like we see on the screen here, and just quickly to read from my notes, help you generate change logs from the changing parts of your artifacts. It does cross-references between the source code. Helps you generate mailing lists so that all the developers are informed about the changes to your overall source code and the modules checked in and out. Dependency lists kind of makes sense, and even unit test reports. So what we can see is that, well, Apache Maven is an interesting tool because it has so much functionality in it. The thing about Apache Maven is, well, the industry as a whole kind of likes it, kind of doesn't. There are people that really say, well, this is the way to go, we need a tool like this, and they're very practical about it. But other people that look at Apache Maven and go, well, isn't there a better way to do it? But at the moment, it's pretty much the de facto standard and pretty much the predominant tool, which you, I think, should be looking at. Now, from JDeveloper's perspective and Apache Maven, in order to work within, let's say, the Maven ecosphere, JDeveloper does need to have some sort of support for Apache Maven. Now, in the JDeveloper 11G Release 1 space, pretty much that support was non-existent. In the JDeveloper 11G Release 2 space, we added some features for Maven support, but anybody who had any Maven knowledge basically found it not satisfactory. Now, from our perspective, why was that support, well, inadequate? Basically because our development teams were having to build up the tooling to make the JDeveloper support the Apache Maven product. So finally, in JDeveloper 12C, that was just released a little while ago after this episode was actually recorded, and effectively JDeveloper 12C, Apache Maven is now a first-class citizen in the JDeveloper tooling. You'll even notice when you create a standard Fusion web application that the very last step now is to say, hey, with your ADF application here, do you want to use Apache Ant scripts, do you want to do command line, do you want to do it yourself, or do you want to use Apache Maven for actually building all your artifacts? So from a JDeveloper's perspective, you can see Apache Maven is far more important now. In fact, if you look across the Fusion middleware stack, in terms of tools like WebLogic Server, you will also see Apache Maven is now a first-class citizen. So the recommendation coming from Oracle is that previously, well, we didn't really have any recommendations in build management tools. It was kind of left up to you to work out what to do. But now, because of in JDeveloper and the other Fusion middleware tools, because Apache Maven is a first-class citizen, we have tooling support, support for the POM XML files, support for the repository tools. We really do think that Apache Maven should be something that you should be looking at in order to deal with the build management dependency issues that we've already described. So the final part that we want to look at in terms of the 4 steps to the build process is configuring WebLogic Server deployment plans and any post-build modifications. Okay, so at this point of the build process, you've generated your ADF library jars, your ears, and the wars. But post this, there may be the need with those artifacts to actually modify them post the build process. And you're going, why would I want on earth to do that? Haven't we already gone through and taken all the correct code parts and built the actual end artifacts? Why would we want to modify things? Well, there are files within the actual ears, walls, and jars that have configuration settings that maybe need to be different for different environments, that being development, test, and production. For example, in context of ADF applications, the web XML file has a number of context init parameters that should have different values for dev, test, and prod. Now that end artifact that you generate, the ear, I guess the ear has no knowledge, is it going to be deployed to a dev or a test or prod environment? So in this regard, you may need some sort of mechanism in order to modify those internal files in order to set the settings correctly for the different environments. Now with that in mind, you really have, well, two options. There's something called WebLogic Server deployment plans, which are designed to be configured just after the build process. You configure them and you say, hey, okay, for this option, I want to change it to this. And well, just before you deploy the application to the WebLogic server, you actually invoke the deployment plan on that artifact, and it will make the actual configuration change at deployment time. There is also another option though to actually explode the ears, the walls and jars and actually go in and change the files. So let's look at both of these options and how they work. So there's basically two options in doing these post-build modifications. There's WebLogic server deployment plans and Ant scripts. Let's just talk through those. Now, a WebLogic server deployment plan is something supported by WebLogic server, obviously. And what it does is via the command line, you take your end artifacts and you generate a deployment plan to say, I want to modify, say, the web XML file, and I want to locate this XML entry and say replace the true to false or something along those lines. So this is something the developer would do or the administrator would do from the command line just after the build process. Then at deployment time, the WebLogic server administrator takes the deployment plan and the artifact, and when they're deploying, say, the ear, they apply the deployment plan on top, and WebLogic server automatically takes care of actually modifying the files that it says to do so in the deployment plan. Now, one of the disadvantages of the WebLogic server deployment plan facility is, well, great that it's all automated and all standardized, but unfortunately it will only deal with the standard Java EE artifacts, such as the web XML file and other WebLogic XML files that are specific to that platform. So from our perspective as ADF developers, unfortunately it won't go in and say change the bc4j.xconfig file, which has all the application module pooling settings for ADF business components. And as you remember, there's settings in there that we need to change for dev, test and production settings. So let's just put that aside for a moment. Let's actually have a look at some code and some steps for creating a WebLogic server deployment plan. So here we can see a web XML file, well, an excerpt from a web XML file, and a specific ADF context parameter, which is oracle.adfu.rich.versionstring.hidden. And what we want to do at deployment time is change that value from false to true. So what we do from the Java command line is we execute java weblogic.planGenerator or plan.xml application.ear. And what that does is give us a WebLogic server deployment plan. And what you can see here is it's an XML file, which you can then go in and modify to modify the files that you're interested in. So via the module override, module descriptor, URI here pointing at the web XML file, you can see that basically with an XPath query, so web app context param name equals Oracle ADFU rich version string hidden param value, we're basically turning that into a variable called hide version, and then that variable up above, we're saying, well, hide version, what we want you to do when applying this WebLogic server deployment plan is set it to true. Now, because of that limitation with the WebLogic server deployment plans, we may need to look for other solutions, and one such solution is using Apache Ant. If we take Apache Ant and we allow it to explode our ears and our walls and our jars, so basically uncompressing them, then we supplement it with tools like AntContrib, which adds conditional logic to Apache Ant scripts, and XML tasks, which allows us to do XML path lookups in XML files. We can then use that to modify the, well, ADF or non-Java EE specific files, such as the bc4j.xconfig file. Essentially, you can allow it to loop through those files looking for XML path entries and then have decisions that says, well, if we're deploying to dev or if we're deploying to test or prod, modify this specific value in this way. So Apache Ant often provides a very flexible way for actually building our applications for sure, but also modifying our applications after the fact. So the last thing I wanted to cover in this episode of the ADF Architecture TV channel is the concept of continuous integration, or CI. So the concept of continuous integration was developed to solve this problem. How can you trust that the code that your developers are checking into, say your Subversion repository, actually compiles? So you've got a developer who's going on holiday tomorrow and they're rushing their code in, basically typing bunches of stuff in and checking it in without actually compiling it. And unfortunately your organization, hey, all your other developers are tied up and you won't actually be able to check the quality of that code for a week or a month. How do you know it compiles? You don't. This is a big problem. So continuous integration as a discipline basically says employ a tool, a continuous integration server, such as Hudson, which Oracle offers, and employ that tool to, say, once nightly to run a sanity check or a sanity build on all the code within the version repository. Basically check it out and build it. And if it doesn't build, send an email to that developer and also provide a dashboard, typically a web dashboard, to indicate to the rest of the team and management that, hey, there's something wrong with the build and the quality of the code. And very quickly, by injecting this sort of tool, you'll see that developers take ownership of their code, are much more interested in the quality of the code that they check in, but as well, you basically nut out issues a lot earlier on, because maybe that developer is interested in the quality of their code, but because they've gone on holidays for a month, nobody will discover the problem for a month. So now the reporting of the problems, well, it'll happen within one night's time. Employing a continuous integration server at your organization is a software best practice, so very much a contemporary software best practice for software development houses. Now, continuous integration servers basically require a whole bunch of presentations by their own right, and it's not something we're going to cover on the ADF Architecture TV episodes. But what I'd like to do is point you to this book by John Ferguson Smart, an O'Reilly text about configuring the Jenkins server. And Jenkins and Hudson pretty much basically the same types of continuous integration servers because they were forked off the same code line. But in that book, Mr. Ferguson Smart, I should say, has a chapter that talks about a continuous integration maturity model, basically 7 different steps to employing CI servers at your organization. And in that maturity model, he goes beyond just running nightly sanity checks to automating regression tests, automating your deployments to your servers, and taking your CI server to such that it becomes an integral part of your overall server infrastructure and your build software process. So we highly recommend that you look at continuous integration servers as part of your overall infrastructure for your software organization and your enterprise. So that concludes the ADF Architecture TV episode today, where we've looked at the build process and tools and options that you have. Now in the next episode, we're going to look at the deploy options and tools, and specifically what we're talking about there is getting your ears, your wars, your jars, your ADF library jars onto the WebLogic server and the different options you have and the pros and cons. So thanks very much for joining us on the ADF Architecture TV episode today, and we hope to see you at the next episode very, very soon.